Good evening, children. Now you have completed almost all of you completed your practicals. Now it's a time for studying the theory and concentrate on the theory and work hard. Then only you can score good marks. So first of all, please study the theory, then go for the questions. So now let us start with the magnetic effects of electric current and magnetism, Unit 3, with the case studies. So please, all of you, like, subscribe, and share to your friends. Now we can go for the case study. The first one, you can see that the magnetic moment of electron. What is that magnetic moment? Just like in electrostatics, you have studied electric dipole moment. The magnetism also, it is their magnetic dipole moment. Now it is why the magnetic dipole moment of an electron. You can see in the right side one figure is there. In that figure, you can see one electron will be revolving around the nucleus in its own orbit. And the current is direction is also shown. If it is clockwise, if electron is in the clockwise, the current will be in the anti-clockwise. So here it is shown the direction of the current is anti-clockwise, and the angular momentum is also shown there. It is what is it moving upwards? It is the direction is in the upward direction. And the direction of the dipole moment. Why the dipole moment is there? Why? Because the current loop. Now the orbit is considered as a current loop. And the current loop will behave as a magnetic dipole. And that is very important. Why it is behave as a magnetic dipole? Using this right hand thumb rule or its reverse palm rule, we can say, this is the direction of the current and the thumb will give the direction of the magnetic field. If thumb is going up, means the thumb denotes the north pole, and here it will be the south pole. So the north pole and south pole will be there, two poles will be there. So we can consider it as a magnetic dipole. And the direction of the angular momentum is shown there, just opposite to the angular momentum. We can say the magnetic moment, magnetic dipole moment. If a dipole is there, sure they will have having the magnetic dipole moment. So what is actually magnetic dipole moment? Magnetic dipole moment is directly proportional to the current and directly proportional to the area of the loop. So we can write the equation M is proportional to I into A. Or we can write M is proportional to, once again I'm telling M is proportional to I into A. Or we can write M is equal to K into IA. What is K? K is a constant and the value of K is equal to 1. So what will be the equation? M is equal to I into A. That is the equation here given there. M is equal to IA. Usually we will denote small letter M. If another M is there, that is magnetization. So we have to use here small letter M. And the unit of the magnetic dipole moment is current. The unit of current is ampere. And the area is meter squared. So ampere meter squared is the unit of magnetic dipole moment. What is the direction? It is perpendicular to the plane of the loop and it will be just opposite to the angular momentum. You can see in the figure, the letter mu, it denotes the letter mu. Or we can write the letter M. Now let us move on to the questions. The first question we can say, what will be the magnetic moment of electron in the first orbit hydrogen atom? In hydrogen atom, you know that only one electron will be there. Then we can say that only one orbit we have to consider. What is the equation for M? Just now we have discussed. M is equal to I into A. You can see in the right side, it is written M is equal to I into A. So what is I? I is equal to Q by T. That means current is equal to charge divided by time. Then what is time? Time is equal to S by V. S is 2 pi R. That means the circumference of the orbit. So 2 pi R. So what is R? R is the orbit. Sorry, radius of the orbit. And V is the velocity. So we are getting I is equal to, you can see in the right side it is written, I is equal to EV divided by 2 pi R. That you can see there. Then what is magnetic dipole moment? M is equal to I into A. What is I? EV divided by 2 pi R. What is area of a circle? pi r squared. So EV divided by 2 pi r into pi r squared. So we can cancel pi and pi, we can cancel. 1 r we can cancel. What is remaining there? EVR divided by 2. That is the equation for the magnetic dipole moment of the electron in the first orbit of the hydrogen atom. You can see that EVR by 2. That is the correct answer, A, the option A. Now we can go for the second one. The relation between magnetic moment and angular momentum of an electron revolving in the first orbit of hydrogen atom. You are studying both three postulate you are studying. The first postulate related to the stability. Second postulate we are focusing here is the angular momentum of revolving electron is equal to the integral multiple of h by 2 pi. Here we are using that one. So here we can say, what is magnetic dipole moment? We got the equation. It is written there. M is equal to E into NH divided by 4 pi ME. That is the equation. Now I have splitted. You can see in the right side, I have splitted. That means E by 2M. E by 2M and NH by 2 pi. So what is NH by 2 pi? That is L. L is the angular momentum. So E by 2M into L. That is the equation for the magnetic dipole moment. Now we can take L to the other side. That means LHS. So what will be the equation? M by L. That is magnetic dipole moment divided by L. That ratio we can call it as gyromagnetic ratio, and we can put a negative sign there. Why we are putting negative sign? Just now, I will show once again the figure. You can see in the figure, L is going upwards and the magnetic dipole moment is coming downwards. That means it is just opposite. So the negative sign indicates that it is opposite. Magnetic dipole moment and angular momentum is just opposite. Now, what will be the correct option? We can go for the option C. And you just check all the options, whether it is correct or not. So what we have written in the right side, you will get it in A, only the negative sign you have to put. So what is the option now? Option A, that is the correct option. Now let us move on to the third one. The angle between the magnetic moment vector and angular momentum vector. I told you, no, L is going upwards and magnetic moment is coming downwards, just opposite. If it is opposite, what will be the angle? Angle will be 180 degree. So the answer will be correct. What is it? 180 degree. Now let us move on to the fourth question. The value of gyroscopic ratio or gyromagnetic ratio M by L. It depends on the value of the charge, is a constant quantity, depends on the mass of the particle, depends on the axis of rotation. It does not depend on any. Why? Because we have seen it's a ratio. So it depends only on nothing. So what will be the answer? It is a constant quantity, so the answer will be B. Now let us move on to the next one. The unit of magnetic dipole moment in SI system. M is equal to IA. You know the equation is M is equal to IA. I is the current and area, A is the area. So what is the unit of current? Ampere. And what is the unit of area? Meter squared. So what will be the answer here? The answer will be ampere meter square. And you just check the other units also, ampere meter, ampere per meter, none of this. So the correct answer, the correct option, we can click on to the A, option A. Thank you, children. Thank you for watching.